Hello and welcome back to Calculus 1. We are continuing to explore Chapter 3. We covered basic derivatives and derivative rules. We are moving now to product rule and quotient rule. They have specific formulas. And if you compare derivatives to limits, limits can be dealt separately, but derivatives, as you are going to see, cannot. So the product rule formula looks like this. The derivative of f of x times g of x is equal to f of x g of x prime plus g of x f of x prime. So this is called the product rule. And anytime when you see two functions multiplied, you have to use this formula because it is the only way to take the derivative. To give you an example of this, we are going to talk about the derivative of x squared times e to the x. You really can't cheat with algebra here because the x squared and e to the x cannot be multiplied or simplified with algebra prior to doing the problem. So to take this derivative, we are going to realize that our x squared is the first function, f of x, and e to the x is the second function, g of x. And you are just going to use the formula to compile the right-hand side. So we see that the first piece is f of x, which means copy x squared. And then g prime of x is e to the x. Oh, that's a bad function. Let's use e to the 2x. Because then I will write 2e to the x, 2e to the 2x here. So then we know that we actually took the derivative. There we go. And then plus copy the second function, which is g, which is e to the 2x, and then times derivative of f, which is 2x. So to continue this so this is your f of x, this is your g of x prime, this is your g of x, and this is your f of x prime. So do we all see how this works? You look at the function, and then you say the first one is f, the second one is g, fg prime plus gf prime. If you don't learn the formula, obviously you can't do anything.
Where did the 2 come from in front of the x squared?
The derivative of e to the ax is a e to the ax. Last class. Yep. Now, the next order of business for this particular problem is to factor out the most you can. Because in chapter 4, we are going to set this equal to 0 to find critical points and stuff. And you can't do that unless you factor it. So get used to factoring your answers as soon as you can. So I will factor out 2xe to the 2x. And what's left is x plus 1.
Wait, how do you factor out the left? When the factor be just x,
I have x, I have 2, I have e. I have e, I have 2, I have x, right? So I factor out common terms. And this is where our chapter 3 problem ends. In chapter 4, you'll say equal to 0, then you solve those equations, and then you continue working. So this will be like 5% of the problem done for chapter 4. But right now, that's it. One step at a time. So the product rule formula is simply memorize it and then use it. Now, some people like to see this formula in terms of the function variables u and v. So the other form is u times v prime is uv prime plus vu prime. This is the same, obviously same formula, is just using kind of different notation for it. U is the u of x, and v is the v of x. So two functions u and v. The reason why we are actually using this is because in Calculus 2, in Chapter 7, you are going to learn integration by parts, which is going to be backwards product rule, and that one is utilizing u and v. So you can remember either FG version or UV version. As you can see, they're both the same. They both start with copy the function, derivative of the second function, right? So copy the first function, derivative of the second function, plus copy the second function as is, and then times derivative of the first function. Now, when I was a student, that's the way I remembered it. I go very fast in my head, and I just say, copy the first derivative of the second plus copy the second derivative of the first. That's how I remember the formula. I didn't remember G, F, G, U, V. I just went copy the first derivative of the second plus copy the second derivative of the first. Because you always have first and the second function. But whatever, just get it right. All right, let's see. Another example over here. How about the derivative of x cubed times the square root of x. Okay, so how should we do this problem? What did you do? I'm interested. Did you use product rule? Why? This is simply x to the 7/2, and you just use the basic rule. Yeah, you unleash algebra upon this question. Yeah, it's okay. Face palms are allowed. Now, can you do this using the product rule? You can, but you can also drive to RVCC through Holland Tunnel every day. Where's the will, there's a way, right? Three plus a half. Algebra. Yeah. Now I'm going to pick some of the homework exercises. So these are the problems that the textbook. Now we are very limited, guys, because we don't have the ln yet and some of the other functions like trig functions. So technically, for most of the problems, you can cheat by using algebra, converting the problem, and then using basic derivative. The only time when you can't do that is when you mix e to the x with polynomials. They don't match. But here are some of the exercises that the textbook thinks you should be able to do. Derivatives of the product. And one of the exercises, number 11, says that you should take the derivative in terms of x of x minus 1 times x cubed plus x squared plus x plus 1. I will encourage you to do this problem in two ways. First way, to use the product rule formula, and the second way, to FOIL it and use basic integration. You must have the same result at the end. Be back in 1 second. So please do it two different ways. The first way is to use the product rule formula right away. The second way is to FOIL it and then use basic derivatives.
I really just like understand it a lot.
Go.
After we're done with product rule, are we done, or do we have to do the order again?
No. Product rule.
All right, so let's take a look at this problem. As I said, for these type of problems, we have two ways. Product rule formula. So copy the first times the derivative of the second, which is 3x squared plus 2x plus 1, plus copy the second times derivative of the first, which is just 1. Right? Because the derivative of x is 1 and the derivative of minus 1 is 0. So now, to put all of this together, you have to FOIL. So it's 3x cubed plus 2x squared plus x minus 3x squared minus 2x minus 1 plus x cubed plus x squared plus x plus 1. And then we collect like terms. So we have x cubed plus 4x cubed, and then x squared minus x squared, so no x squares, because they're all canceled. X minus 2x plus x, they cancel. And what? Is this good? All right. Wow. Now, way 2, possible because this is something that we could FOIL using algebra before we start working on these problems. So we have x to the 4th plus x cubed plus x squared plus x minus, there you go. That's why. It's x squared minus x minus 1. No, minus 1. Yeah, minus 1. And all of these terms drop because they subtract to 0. And you have your derivative of x to the 4 minus 1, which is just 4x cubed. So in some cases, right, when you have polynomials, you can multiply first and then take the basic derivative. But as soon as you start mixing different types of functions, where the polynomials and square roots are not compatible with e to the x, with the trig, with ln, you will have to use this rule. So you must know it. It's just that we didn't cover enough material and enough functions for you to actually find that this rule is absolutely necessary to solve things. One more example from textbook. So find the derivative in respect to t this time. And the problem is 4e to the t square root of t. This is problem 14. Now this one can only be done one way, which is the product rule formula.
Wait, so which class preps are due tomorrow?
Next 3.
So what's that? 3, 5, 6, and 7.
Whatever is after what we do today.
Oh wait, what was it today?
Yeah, the good thing is that you have the syllabus and stuff.
This one with square root of t. Technically, it's just t. Why is it t negative 1/2 first? Because you're doing the n minus 1 to the negative 1?
Mm-hmm.
I mean, to the positive 1, so it's b negative 1. Okay, alright, thank you.
So don't forget to factor at the end. It's very important to factor at the end so that you can continue with the problem in chapter 4. Practice factoring as soon as you can, which is now. So use the product rule formula, copy first function, the derivative of the second function, plus copy the second function times the derivative of the first function. Happens to be the same thing because it's e to the t. So we can factor out 4e to the t, and we are left with 1 over 2 root t plus root t. Moving forward, this is going to be equal to 0. The first part will give you no solution. The second part will cook up something, and so on. Good. That's the first half of the lecture. The second half of the lecture is quotient rule, which is again a formula. You use the same way, just plug and pray. So quotient rule will be the derivative of f of x divided by g of x, provided that g of x is not 0. We'll take g of x square in denominator, and we have g of x f prime of x minus f of x g prime of x. So it's backwards from product rule. So quotient rule, and immediately example so you can enjoy this. So we have the bottom function, which is g of x, will be squared as is. And then we have copy times the derivative of the top, which is 2x, minus copy, and then times the derivative of g of x. So g f prime, f g prime, and g squared. Now, clearly there is some algebra to be done here. So we have 2x squared plus 6x minus x squared minus 1. Do not FOIL the denominator. Always leave it squared. Because later on in chapter 4, you set it equal to 0, it gets wiped out. So it doesn't matter. Don't waste energy. You don't need to do it. That's that problem. I will pick 2 examples from the textbook. Go.
Do 3.1 over. Wait, so what happens to, I don't know, so if you have x, I'm doing 3.1 over, so I'm trying to learn 3.1. Wait, I got a question.
No, somebody made this name for Android, and I thought it was that it is yeah, I played something about
I got a quick question. So You had 2x, so I'm gonna mess with 1, huh? I just mess with x squared. Then I can't see you. Baseball?
He doesn't mention anything.
What does it say? I have.
Somebody's writing my quotes. It's gonna probably be a book or a website or something after.
We got more. Yes. You're out there every day.
Yeah, I always say something. All right. So we take the denominator and square it. Then we copy it as is. The derivative of e to the x is e to the x minus copy e to the x and then 2x. So what can we do here? We have x squared e to the x minus e to the x minus 2x e to the x divided by x squared minus 1 squared. I can factor out e to the x, and the remaining is x squared minus 2x minus 1 and x squared minus 1 squared. That's it. That's the factored form. One more example from the textbook, because they love this stuff. All right. I don't know if you want to label this one as spicy or annoying, but here it is, 28. Find the derivative of, it's written in a weird way.
Oh my god.
Oh. 4x plus 1 is on the bottom.
There you go, yes. So this negative one drops it to the bottom, so it's a quotient rule. Go.
I'll get my light started.
Exactly, because. All right, let's take a look. So this is a problem that we first have to rewrite to make it into a quotient rule. So 2 root x minus 1 divided by 4x plus 1. And then we take the derivative. 4x plus 1 goes in denominator squared. Then 4x plus 1 times the derivative of the numerator. Well, this would be 2 over 2 root x, and then 2's cancel. Minus 2 root x minus 1 times the derivative of the denominator is just 4, because the derivative of 4x is 4 and the derivative of 1 is 0. So now to simplify this, we have 4x plus 1 divided by square root of x minus 2 root x minus 1 divided by 4x plus 1 squared. We have a square root of x, so to make this look a little bit, yes? Oh yes, thank you. There's a 4 there. So I'm going to multiply square root of x to get rid of the square root from the denominator there. And we get 4x plus 1 minus 4, and when I multiply square root of x through, I get 2x minus root x. And then on the denominator we have root x times 4x plus 1 squared. So now this is equal to 4x plus 1 minus 8x plus 4 root x divided by root x. So there's just a little bit of algebra to help with simplifying this. So this works out to be 1 minus 4x plus 4 root x divided by root x 4x plus 1 squared. The final stage is we don't like the square root in the denominator, right? So we multiply one more time by root x to get rid of that from the denominator, and we're done.
You don't want us foiling?
It won't help. It's going to still be around. Because square is not applied to the root. You will have to FOIL 4x plus 1, and then when you multiply by root, it stays in every term. Minus 4x to the 3/2 plus 4x divided by x times 4x plus 1. So a little bit of algebra here, just to make things interesting.
Back.
Yep. I can see. All right, let's see what you can do with this problem.
Comments will stay there. Like on the live stream.
Which one?
Like the live stream, if I make a comment, like through the chat, maybe it will stay there. When I go back and watch it later, I want to click the points because now I will stop right now.
Mm-hmm.
I don't click so I can skip over the stopping part. I get to when it's like, so it will stay there.
Not sure. I'm really not sure, but you can always move the slider, and when you see me writing, right? As soon as you start to see something change, right? Because when you slide, it doesn't do anything with the sound, just with the video. As soon as you see me start writing, it started.
You know what I'm saying? No, like sometimes you put like timestamps.
Oh yeah, but that will take editing and doing all of the other stuff. Unless you want to sit and do that. All right, guys, so what is interesting about this problem? We need to use both rules in the same problem. Very good. Now, which one is the main rule? Quotient is the main rule. And then when we have to do f prime, that's when the product rule kicks in. All right, so this is one of those little bit evil problems. We need both rules. So quotient rule is the main rule, which means we have x plus 3 in denominator squared. Copy x plus 3. And now I have to do derivative of the top of f, which has the product rule. So now this is the product rule here. Copy the first one, derivative of the second, plus copy the second times derivative of the first. So we did the product rule there, and then plus copy the, oh sorry, minus. Copy this one, and then times 1. So as you can see, it's a little bit spicier example.
Is that a 2 or a 7?
It's 2. So if you look at the numerator has two functions that are multiplied, which is the reason when we have to do f prime, we have to do the product rule. So the entire problem is quotient rule with a product rule embedded in it. So we know the formula, g squared and then g and then f prime. We have to do product rule. And then minus f times g prime, which is 1. And now you simplify this and we're done. Well, we have one more problem, obviously, but the most important problem. But then we're done. So to simplify this, we have x cubed e to the x plus 2x squared e to the x plus 3x squared e to the x plus 6x e to the x minus x squared e to the x divided by x plus 3 squared. We don't have any other x cubes, so x cubed e to the x. Now this is 2x squared, 5x squared, 4x squared. And then we have plus 6x e to the x divided by x plus 3 squared. And then we can factor x e to the x, and the rest is x squared plus 4x plus 6 divided by x plus 3 squared. And that will be the simplified version of the answer, ready to be placed for x equals to everything equal to 0 to find critical points, min, max, everything else. Are you ready for the most important problem? That's the enthusiasm. Find the equation of the tangent line. At x equals 0 for the function y equals 3 open parenthesis x plus 1 e to the x. Find the equation of the tangent line. Same procedure like last class, except you have a different way to take derivative. I told you that in this chapter, chapter 3, you will have find the equation of the tangent line in every single section. Because to find the equation of the tangent line, you have to take the derivative. We're just learning different ways to take derivatives, but the application is always the same. Find the tangent line. Does anyone remember from yesterday what is the procedure for the tangent line? Yes? No limits. We have quick formulas. Guys, what are the steps for the tangent line? Yes. Find the derivative.
Yeah. Oh, yeah.
Substitute x equals 0 in this case, and you get what? Which concept? The slope. So then you have the slope, you have the x point, plug it here to get the y point, and then you have x, y, and f, find p, and you're done. How's the tangent line? Pretty well. accidentally watched the stream and now you just. Yeah. All right, so you find the derivative, you plug in 0 to get the slope, and then you plug in 0 in the original problem to get the y. You have x, y, m, find b, and compile the line. Should be very straightforward, very quick. And that procedure stays the same for every section. It's just a matter of the way you're figuring out the derivative. We first figure out the derivative for tangent line using the limit, then basic derivatives, now product and quotient, in the future, trig, inverse trig, implicit, logarithmic, all these different kinds of derivatives. But this procedure is always the same. You find the derivative with whatever rule you must. That's how it goes. So you use appropriate rule to find the derivative, the rest is the procedure for tangent line. Calculate at the point to get slope. Keep going.
Yeah, so you just write it when it's due, you just send it back. I think I read the entire, I got this for the entire course, it was like $45. Yeah, I guess. They do it in like two months. 2 months is like 20 something. Oh no, sorry, 1 month is like 20 something. I did 2 months because five weeks. So it was like 40. So if you did it, you could do it like the first semester and the second semester.
Oh, I thought that you know, I understood that you took it for the entire course. You said, wow, this course $5 for the entire year and a half.
No.
I know you are. I thought, I want to do this first. I was going to use this first.
Yesterday, but you want to break it.
You're doing it all day.
So we find the derivative. What's the derivative in this case? What do we have to use? Product rule. So copy the first, derivative of the second, copy the second, oops, that's a plus, didn't hit the shift. Copy the second times derivative of the first, and then we simplify this, so I can kick out 3e to the x, and what's left is x plus 1, which is 2. Okay, so that's our derivative. Now, the slope of the tangent line is the first derivative computed, in this case at 0. So that's going to be 3e to the 0, 0 plus 2. And that's 3 times 1 times 2 is 6. So slope is 6. We plug in 0 in original equation to find y value, which is going to be 3 times 0 plus 1 times e to the 0, which is 3. So we have slope is 6 and the point is 0, 3. We plug that into y equal mx plus b. So y is 3, m is 6, x is 0, plus b. So from here, clearly b is 3. And the equation is y equals 6x plus 3. That's the tangent line at 0. Procedure is always the same. The only thing that's going to be different from problem to problem is the way you find the derivative. Is it basic? Is it chain rule? Is it product rule? Is it quotient rule? Is it implicit differentiation? So something will work. As soon as you're done with the derivative, you will plug in the point and you will get the slope. You will plug in the point in the original formula to get y, and then you will find b using algebra. There you go. So that's the 3.4 product rule and quotient rule. We are going to restart the stream and do derivatives of trigonometric functions. I know, fun. This is your Calc 2 prep starting today. All right.